Hello, in this we will study band reject filter. Okay, so band reject filter, if you here also we can have two things. One is wide band reject filter and narrow band reject filter. Okay, like in the band pass, here also if Q is less than 10, then quality factor is less than 10, it is wide. If Q is greater than 10, it is narrow. Narrow band pass is also called notch filter. Okay, so we will discuss wide band reject filter. We will discuss. So the general response of a band reject filter, so wide band reject filter, so general response will be like this. Okay, so one cutoff frequency here, and now this is nothing but a low pass filter and this is nothing but a high pass filter. So if you use a low pass filter and a high pass filter, you can realize a band reject filter, but how to connect the LPF and HPF is important. In the band pass filter, we cascaded a HPF and LPF, but here you cannot cascade here. You have to use a summing amplifier. In that summing amplifier, you have to add LPF and HPF. We have to use the adder. There we cascaded, here we have to add. So difference you just see. In the band pass filter, we cascaded, so one after another we placed, concatenate or cascaded. Here not cascading, it is the adding. High pass filter response and low pass filter response, if you add together, you will get a band reject filter. And one more thing you have to observe, here we will, since LPF is, this cutoff frequency is decided by a LPF, we will call this as FH, and since this cutoff frequency is decided by a HPF, it is FL. Usually we take higher frequencies FH and lower frequency FL, but here since the FH is nothing but the cutoff frequency of low pass filter, and we know that cutoff frequency of low pass filter is called FH, so that's why we are writing like this, and high pass filter we use FL. Okay, so before that I think you should know what is summing amplifier. Summing amplifier, I think you are already familiar. I will just briefly explain what is summing amplifier. Okay, so the summing amplifier is you want to add two voltages, and this is RF. If you take, this is R1 and R2, you apply V1 and V2, and this is V0. So how you can find? You can easily prove this one. This is I1, this is I2, and this is IF, and no current, 0 ampere, no current flows through the op amp. So if you apply the Kirchhoff's current law here, this is nothing but I1 plus I2 equal to IF. From the virtual ground, this will be at 0 volt. So first I1 we can simply write V1 minus 0 divided by R1. Here V2 minus 0 by R1, and this one 0 minus IF is from here to here, 0 minus V0 divided by resistor is RF. So here it is nothing but V1 by R1 plus V2 by R2 it is, R2 equal to minus V0 by RF. If you take, if R1 is R2 equal to R, if you take, then V0 will be minus RF by R into V1 plus V2. We get a summing amplifier. So summing amplifier, it's a inverting. Just take the two voltages, use resistor and connect to the inverting terminal, and one feedback resistor. Opposite non-inverting should be grounded. Then you will get a summing amplifier. Maybe inverting, but is the summing amplifier. It will add these two. So this is how you will find. Now see, instead of summing V1 and V2, we will sum the same signal. But what happens? Let me show that what is the logic. You use a LPF and you use HPF and you add and you get the output. This is V naught, okay, and you give V in, okay. So response is this is the response. You here this is FH and this is FL and this is LPF and this is HPF. Now what happens, same signal you are passing, okay. So what happens, till 0 to FH this low pass filter will work. During that time high pass filter gain will be 0 during 0 to FH. So 0 to FH LPF will work and HPF will be 0, that is 0. The total output is nothing but the LPF only you will get. So this response only you will get. From FH to FL, both filter, low pass filter also will not allow, HPF also will not allow, because low pass filter cutoff frequency is FH, high pass filter cutoff frequency FL, where FL is greater than FH. So this during range both LPF and HPF will not conduct, or will not conduct means will not allow any frequency. So you will get a 0 volt here, okay. And finally greater than FL. So greater than FL, when you get your LPF, it will not work, but HPF will work. So you will get a HPF response. So this is the logic of a band reject filter. Now what we have to do is, depending on the roll off, you have to select the LPF. If you want 20 dB, go for first order, 40 dB, go for second order. Now we will see complete circuit. I think this is very straightforward and very easy. So let us see. We will first design a band reject filter with plus or minus 20 dB. So circuit diagram, let us see how it is. And also you try to maintain here the gain of LPF and gain of HPF should be same. Then you will get the same pass band gain also. Here also same pass band gain you will get. So gain should be same. Okay. So let us write this one. Minus plus, this is we will call it is R1, RF dash we will call. Yes, we can call R1 and R not RF dash, RF, okay, R1 and RF. This is grounded. And here low pass filter we will use, and low pass filter, okay. So this is R and C, we give V in here, So cutoff frequency is, this is a low pass filter 1 by 2 pi RC. Now this one we have to add RI1, I will call this one. And one more we have to add, this is a LPF. Now we will see one HPF. So again HPF we have to use minus plus, and we will use same this one, gain should be same. So R1 I will write same, R1 and RF1 only you have to use, ground, and here you have to use a high pass filter. And this one is decided by C dash and R dash, where FL is decided by 1 by 2 pi R dash and C dash, and this is also given by the same input you have to give, and this I have to add. So RI2 I will write. See that how we added in the summing amplifier, just see, voltage 1, voltage 2, use resistor and feedback resistor, same this thing you do that. High pass, low pass filter in signal, high pass filter signal, and you have to add both. So it is, you have to add this one together. Now you have to use another in summing amplifier. So then that means you have to non-inverting ground, and you have to use a gain. So you can call it is RF RF2 you can call RF dash or RF2. So I think here one nomenclature, this one is RF1 only. So we have written R1 RF1. So RF2 you can call, and this is what your V0. Okay, so this one will give me a band reject. So we will see one example, then you will understand very easily here. So let us design a wide band reject filter, with FH 200 hertz and FL 1 kilohertz. Okay, with the pass band with gain equal to 2. Okay, since gain equal to 2, but FH and FL, so FH means one low pass filter is given, its cutoff frequency is one low pass filter LPF with cutoff frequency FH equal to 200 hertz. This you have to design first, then an HPF you have to take, where you have to keep the cutoff frequency 1 kilohertz, and then you have to add these two. Okay, so directly we will, and the input should come from same signal input come. So first we will see LPF, we will see, and LPF cutoff frequency is FH, that is 1 by 2 pi RC, and that is nothing but 200. So you can again depends on the capacitor. So since FH, you can take this capacitor, it's a low pass filter we are writing. Low pass filter you can keep C, if you keep 0.05 microfarad, and R what you get is 15.9 kilo ohm you will get. This is LPF. HPF, if you write HPF, it is FL you have to write, it is 1 by 2 pi RC again, and that is equal to 1 kilohertz. Okay, so that again you have to select. If you select C equal to 0.01 microfarad and R you will get 15.9 kilo ohm. Okay, so both filter we have designed. Now the gain required, gain should be 2. So gain should be 2 means what you have to take is, we have to consider, just see, gain of this is nothing but 1 plus RF1 by R1, that will be multiplied with RF2 divided by RI1 minus of that. So what you have to do is, this gain total gain should be 2, so I will keep this gain equal to 2, this gain 2, and this gain will be 1. So like that we will do. So gain of LPF gain is nothing but 1 plus RF1 divided by R1, this is 2. So RF1 equal to R1 equal to 10 kilo ohm. Okay, just see, let me write that there itself. So this one is 10 kilo and 10 kilo. Similarly, high pass filter also you want same gain. So here also you use 10k and 10k. So you will get total gain equal to 2 here also you will get 10. Now gain from here to here you have to write, because the final result will be V0 equal to RF2 by RI1 into the gain of this. Another one RF2 divided by RI2 into gain of this. So let me keep it same, 10k only I will keep. So this also 10k, this also 10k, and here also 10k. So second stage you are not going to get any gain, it is 1 only. But first stage you will get 2 here also 2. So total gain is 2 into 1, that is 2. So you will get the total pass band gain equal to 2 you will get. And the response will be like this. So if you plot, so response is 1 minute. Okay, so this gain equal to 2 and this cutoff frequency, one is 200 and another one is 1 kilohertz. And this roll off, if you plot in dB plot, in dB scale, it will be plus 20 dB per decade, and here this is minus, that is minus, because high pass low pass filter it is minus, and here the roll off will be plus 20 dB per decade. Okay, so that is how you design. Okay, thank you.